Good evening, everyone. Today, we're going to talk about hash collisions, multi-hash collisions, like not just two pair files, and let's extend that to hashquines. So first, let's already long ago, Mark Stevens. So again, feel free if you have questions. I'm watching the chat, and don't hesitate. Don't hesitate to ask questions. And yeah, so already long ago, Mark Stevens. Oh yeah, so sorry. First things first. Make sure if you're not familiar with the various topics to check my playlists with my various streams. And for these ones, the ones that you might need would be definitely the first one, the number 18 on hash collision exploitation. This one, maybe not. Crypto polyglots, not either. And if you're not familiar with file format manipulation, yeah, maybe you should go back to a few file formats manipulation like PNG and PDF, so that you're more familiar with it. And if you're not familiar with file formats in general, maybe look at the PDF basics ones and then the leaks and parasites to just have an idea of manipulating these file formats. And then you can go back to the hash collision part, or I mean, it's up to you really, but polyglots, maybe if you're not familiar with multiple files manipulation. Again, this is gradually getting harder. And so basically now we already did several streams on hash collisions and weird file stuff. So yeah, now basically Mark Stevens did an attack which chain a few hash clash collisions into a multi-collision consisting of any number of messages colliding into the same hash value. So basically, you do a collision, you collide two files. At this point, the hash of either A or B is the same, and then C or D is the same, and then you end up adding new hash collision to eventually get all the same contents having a single hash collisions. As usual, the value of the hash is not known in advance, but it will be identical. And basically, he did a multiple 12 file 12 PDF collision, where each of the PDF is showing the name of a presidential candidate at the time. When was that? In 2008. That's quite some time ago. And he added two unknown profiles, which I don't know, even though Paris Hilton, I'm not sure she was actually, I know Pravin Frey, I'm not sure they were actually US candidate. But the thing is, the files look pretty simple. I mean, simple, normal. And they are actually using so if we look at, for example, two files that collide are A and B, John Edwards and John McCain. So John Edwards and John McCain, and we will see that they are indeed starting the same, ending the same, and there will be naturally some hash collision in the middle. And that's about it. So basically, there will be some stuff that is replaced, it works, and indeed, it's a funny result that you could that way. Mark was in 2008 in advance sure of showing the right document with the actual presidential, and today is President's Day, so it's actually funny. Funny coincidence. And yeah, so the collision is, as mentioned, the collisions are in a hidden image that is non-referenced. I'm not sure if it's referenced. It could have been just a stream object altogether, I guess it's will be pretty easy to guess where the collisions is. This is fladical. This probably a right image, and this is maybe not. I don't know. But in any case, if the comment is not, if the stream object is not referenced, there's no problem of compatibility, because PDF readers are so tolerant. One thing is about the two hidden candidates. I don't think you can actually get them from the actual files, because again, it's chosen prefix. So you cannot guess when chosen prefix collision. You cannot guess the other file's content. Um, I mean, as far as I know, there's no technique to even have s- possibilities of making sure you have the right. I'm not aware of any technique that would say, "Hey, if there's a slash collision, I don't have the other file. Then can we guess something on the unknown content?" Because otherwise, if that was the case, maybe we would have some information on, for example, the Flame malware, which was an unknown hash collision, and we only have one side of the collision. So that's it. In 2008, Mark was already saying that MD5 should no longer be used as fingerprint function for electronic documents. And just last year, sorry if I'm forgetting his name, but the blast radius research showed that as long as you don't Miro something, Miro MD5 blast radius. Oh yeah, this is here, blast radius dot fail. And again, the important thing about the blast radius, it was a new kind of MD5 collision for more efficiency. Yeah, exactly. Sharon Goldberg, Mario Haller, and so on. Mark Stevens, of course, for the and the crazy thing is that just before the hash collision, the blast radius collision was released. Basically, the people behind the working on the radius protocol were saying, "Hey, it hasn't been broken yet, therefore it must be robust." So basically, in 2025, people still consider that if it's not broken in practice, then it's probably safe actually. So this prediction, haha, this Nostradamus prediction from 2005, 2008 that MD5 should no longer be used is still wrong. In 2025, people still assume it won't be broken. It's safe. It's not if it's not broken in practice. Okay. Um, so I'm not sure there is anything here that can hint at getting the actual files to be to guess the missing two files. And then yeah, if oh sorry, in case you didn't know, I have a repository of on hash collisions, and I'll base that on a lot of stuff in next. And also I have one on we will see a few Poker GTFO files, and the files of Poker GTFO are, for example, on my GitHub. So this and this one, Ange Albertini, Poco GTFO. You will see a few weird files there. And one of the file that we're gonna get is Poco GTFO 19, if I recall correctly. Is this one? This one? Yes, exactly. This is a multi collision. I showed it in a previous on the episode on the stream on Poker GTFO polyglots. So this is a PDF, and it has some ASCII art because why not in the prefix. And then I'm documenting stuff, and then there's MP4 and PDF, and then there is whatever this is looks like. Okay, no spoiler. I mean, if you're familiar with it, this is clearly MP4 chunk atom. Anyway, so basically the way it works is that it's a PDF, right? I guess it's a pretty standard PDF. Okay, this is a PDF with nothing special. And if you rename this PDF as HTML, oh, did I do a mistake? Oh, two dots, okay. And you drop it, why won't it work? Will it work? Oh, I did a typo. Oh, interesting, the extension is wrong, so it still opens it as PDF. Now as HTML, it's a HTML polyglot, and this file is a hash pileup and HTML polyglot that collides itself, and it's a polyglot, and the file is currently an HTML file, and it cannot open itself. So you have to drop the same file again on itself, and then, okay, it didn't work. They do mistake. Yes, and then it identifies the problem again, as I mentioned with the identical the chosen prefix collision, is that you cannot get the other part side of the collision just by itself. So in this case, instead we made the so let's look at the file again, and now let's look at source. there is this, and then there is the HTML part, and the HTML part is exactly what you see in the background. But also there is some code that will match the current prefix of the file to the existing prefixes. So you see now it's a prefix mp4, prefix p, and basically that way you can save the file again with a new prefix that is stored in the JavaScript. And then you have actually, so the executable is, people, you might be familiar with that because I do that a lot. PDF viewer, will it work? Yes, maybe it will not. Yeah, exactly. That's PDF viewer. So that's the usual Sumatra, the patched version that I created. And then there is a small video. Will it work? Hopefully it does. This is very short, but you could see it animated. It's a small MP4 that is looks like a that's a collision. And now the last one is an image which we're going to study, because it represents the actual structure of the files. So this diagram is more or less what I came up with when to design this file, because with such complexity, I needed to have everything perfectly planned. So all formats kind of start at offset 0. The only exception being, I mean, technically MP4 files start at offset 0, but it starts with a length that you could abuse for some limitation. So it's not technically a magic signature at offset 0, but it's still something that is checked and parsed. Okay, percent PDF. The PDF part is very clean, so I wanted the PDF signature to start at offset 0, even though, as you may know, this is not strictly required. And so basically, for the P file, you don't. This is the prefix, and the only thing that is important in the P header is at offset 3c the pointer to the next to the actual P structure. So 560 will be the point. The P header is here. Okay. So this is a an empty the DOS header. And all this is ignored because we are jumping over it because of the pointer to the P header that is basically jumping all over all this structure. The PNG, so the P header is the one that has the most freedom from the very beginning. The PNG, the MP4 one is nothing special. I mean, not nothing special, but basically it starts with a free atom. So MP4 atoms are a length type values. So basically the length is first, and then the value is here, and you end up, as you see, to the declaration of another free chunk. So you just hop from one free atom to another one. So as you can see, there will be chains from one to jump over actually it's a chain of jumps. It's not in 540. For you see, my diagram is a bit shortened. I'm not sure why. Okay, and the PDF one is the usual stream PDF object declaration. And then as long the length is actually referenced further in the file, so that it will be even a very valid stream object. And then you just need to basically look for end stream, and hopefully that works, because again we are jumping over a P file that is a PDF viewer, which would contain PDF keywords such as end stream, but I compressed it with UPX. Okay, so then you have all these headers working together, I mean in parallel more or less, and then you need to jump. So the first things, I'm not sure why the free chunk is there first and not the P header, but yeah, you need to jump. Basically, you need those two to the PDF can easily jump over everything. The length is referenced further, and the PNG and MP4 are very flexible themselves, and it's quite important to not put the P header too far away in the file. It's not a comment; it's just a pointer from the DOS header. So Then there is the DOS header, the pointer to the P header, and then there is the rest of the P, and the rest is considered appended data for the P. In the case of a PNG, there's PNG signature, a declaration of a chunk with a lowercase first letter, which means it will be ignored by parser, which means this file will be invalid on Apple viewers. And then you end up jumping over. This could have been jumped altogether, but since this was fixed already in the case of collision, this is after collision, so this can be adjusted for any length. Because again, this is not just a multi-collision, not just an MD5 pileup. This is a completely reusable MD5 pileup, which is why the length here are just the bare minimum to jump over the collision blocks. And then you can resume, you can adapt this length here, and for the ones here, and the length of the object here to whatever size of payload you want to adapt to want to include. So basically, this is fully reusable, generic over 4 file types. So which is quite interesting, because even better that all these 4 file formats are very standard and all start at offset 0. So it's like a very powerful demonstration that hash collision can be much more than just 2 files together. No comments. Okay. So yeah, that's about it for this pileup. Reusable, and even better, then after this, I could add some HTML code to see the payload that you saw working earlier. Do I still have it open? Yes, exactly this one. So you can regenerate the files themselves. And the only one not being fully compatible is the PNG file, because of this, the first chunk being not the image header chunk. Okay. So what's now I'm done with the let's put it that way, standard file types generic collisions. I don't remember doing it more than that, but then one question is very important: why put only 2 colliding files when you could put colliding when you could create something that has, like, for example, 609 collisions, which would be a huge number. That's 184 digits of possible colliding files, and those things are called, because in this case we are talking about hashquines. So on my collision repository there is a hashquine page, and let's see what it's about. So basically, hashquines, so there you have, here's the page, you have the hashquines themselves, you have scripts to manipulate the hashquines. So if you want to reset them to make them display something else and still keep the same hash, this is exactly what they are for. And yeah, so basically let's start. And basically a hashquine, okay, not that one, but I have a local copy too, this way here. So basically are just files showing their own MD5. And how does it work? It looks like a magic trick, but it's actually you made it possible to display any value, or at least the value that you want. It's not necessarily any value as we see, but just the value of the actual hash of the file. And you make it happen before, it's not pure brute forcing, of course. You make it happen by putting enough hash collisions so that you can change the display of the file while keeping the same overall hash. To be honest, it's not even required. We will see some corner cases, but in general, you just add enough hash collisions so that you can just write any hash collision, any hash value, therefore also the right one of the file, without any brute forcing in the end. So of course, a hashquine could be cheating by just having a program that checks itself, reads itself, and compute the same the hash of its file, right? Another kind of hash collision, another kind of hashquine is that you don't change the way the rendering, but you just store data and you put enough hash collision that will act like a bit, because hash collision has 2 sides, right? And then you will be able to, depending on the actual value, you will be able to swap the values of that collision while keeping the same MD5. And this adds a little bit like, is it the side A or side B? And then you end up encoding an MD5 in itself. And this is the first This is the first hashquine that was created by Gregor, and this is done in PostScript. And where is it? Where is it? Why can I see? Yes. Okay. So this is the PostScript one. Can I actually display it? Or will it crash my system? This, yeah. Okay, it works. Okay. So this is the PostScript file, and you see that it just so this is a hash collision, and then he just added how do you say, a value of the collision, and then it compares if they are equal, and then it's one if not zero, and then it repeats that, and it repeats that with another hash collision that was appended and compares to a possible value. So you might see that there are indeed some differences. You see that the alignment here is not strictly the same. There's probably those two are probably different somewhere. I'm not sure where I should look. Here, fs, yeah, exactly, this fs and gs. So here these two values are different, and basically you will get a non-equal, and so on, and you end up encoding every bit of a number that will be in the end generated. Then all these bits will be gathered together to display the actual MD5. So it's just a program that with some stored bits that are stored in a very awkward fashion, where this is a value that is compared to possibly identical value. Here you can see again that there is a difference. There JDASWP, and here is JW, and there is a new line return. So you can see that these two values are different, and here it looks like these two are identical. So here, not encoding the same bit value. So this is the easy case, like I would say, the code case of hashquines, where you store the value by bits, and then there is some code being displayed. And of course, the other way is just to use a file format structure, so that it's the rendering is different. So this one, I like it, that there is even some animation. And the best part is that when you code a segment, 7 segment display, then you can encode more values and not having to encode all 16 values of this nibble. So basically, you are storing the number of collisions that you are required. I also like that one. So both were done by Christopher Janku, SPQ, sorry. And this is, it's done from Alien versus Predator, the Capcom CPS2 game, which I contributed decrypting in the past. And this is just a small animation showing the actual hash byte per byte. So what else? Some of them are what is there? Was there? Oh, this one is another GIF one by Rogtham, and he put MD5 is dead with some animation, and it's the same trick. But here, you see that it could take more time if you want to display all the possible numbers, right? And he did some brute forcing to hard code these values here. So the dead and MD5 and D5 are not possibly possible to swap in this file itself. They are hard coded. Let's put it that way. I know because I wrote the script to actually modify this. So if you want to display the hex value, you need 16 characters for 32 digits. So that's like 440 collisions. But it's only possible to turn on and off each number and not to choose between two digits. Then you have like, do I display 0? No. Yes. Do I display 1? Yes. No. So it can be actually more than that. So it basically just reduces the number of hash collisions that you require if you use some tricks. Mako did 2 on PDFs, and they were pretty clever. And will they work? Okay, this one works, and I'm not sure. Oh, they both work. So one is text and one is an image. And the text one is like pretty clever. Oh, I thought it was creating a mistake if you copy paste on it. So the JPEG one, so the MD5 JPEG, as you could see, JPEG cannot embed PNG or the file formats, just JPEG and TIFF. And TIFF is possible to do Hashquine, but the Hashquine barogram on TIFF is super heavy. It's 4 GB because of some offset becoming too big, and also the value is encoded as bits being displayed. He created a very nice, I think this is not the actual TIFF, it's not a 4 GB file. Why cannot I display it? Oh, this file is weird. Okay, but it can be displayed. That's weird. Okay. Where pics TIFF. There's not a TIFF picture. Yeah, TIFF preview. This is the file. Sorry for being 4 GB. And this is a full. The file is not doesn't display directly the MD5 value, but at least it's a nice write-up itself. So what else? Yeah, so the PDF text one is actually so the JPEG one is so let's see, this is the MD5, the JPEG one, and basically you have a PDF signature, an image declaration, and filter DCT decode, meaning it's a JPEG compression, and then you have here the magic FFD8, and then FFE0, which is app 0 segment, which means it has the JFIF marker and so on. And then FFFE here means it's a command declaration of a length of 71. And you land exactly in the middle of the fast call block here. So that's a fast call block. And Mako was clever enough to modify Fastcall so that it actually encodes in the Fastcall, or you can do that by just brute forcing Fastcall until you have the right bytes, or you can add the new condition to not terminate, to not finish the Fastcall computation if you don't have a FFFE here. And basically, he made so that it declares in the fast call, so it's a modified fast call, so that it takes a bit longer, but also encodes a new JPEG command that will jump to a new, you know the drill, to further or closer and so on. And he changed such fast call blocks. So this is again a fast call block, and here is the declaration of a command segment, and so on. So this is for the MD5, the JPEG in MD5 PDF, and the text one is more complex, and it's basically declaring a lot of objects. And he did a similar thing, but in a very different way. I mean, quite a different way. And here he's using the hash to declare to a modified fast call to declare a do operator, which is to display a particular object inside your PDF stream. So basically, he's completely and after the do thing, this is an actual PDF name. So like a very crazy PDF name that is referenced further in the file. So I'm not going to try to read it, but you see that this is actually referencing, it's all chaining all these references to do objects, which is quite crazy for and okay, so I don't know if you saw, but basically it starts with the slash, which means this is a name. This is a PDF name, and basically what you need is that there is no white space in all this crazy thing. So basically, all this first pass of the collision block is an actual PDF name, which I will not try to read. And then for that name, it's referencing this operator with this parameter, which is another PDF name. So basically, Mako is completely abusing PDF names that, as long as they don't have balance, they have balanced parentheses or no new line, or no white space, sorry, it's fine. So basically, this is exactly why here there is a space to separate these two crazy parameters. So, and he repeats this pattern over the whole file by in that way creating different names and different operators parameters, until at the end there is some actual code to just put stuff together. I mean, some code. It's not code, it's not JavaScript code, but it's just PDF objects. So now he can swap the objects themselves. And here you should have the, yeah, exactly. See, he's referencing you can see here that he's defining form one. Where is it? The name here is reference to 10 object 1, and then this name here same for object 2. So basically this is declaring the actual crazy names to refer some objects. So this is the name object of the PDF. So pretty crazy abuse, and yes, it works, so it's pretty impressive. I thought it has some incompatibility on something. Let me try JPEG text. Let's try on Chrome. Oh, it works too. I thought there used to be some bug, but yeah, this is a valid text file, which is completely crazy. I mean, not completely crazy, but you saw the way this PDF works. Yeah, it's definitely not your standard PDF file, and yet it's just selectable text. So good job. Um, what else? What else we have for Hashquines? We did so read, you abuse file format parsing, command segments, PDF hashquines, very nice stuff. Do GIF hashquines as SPQ, and then this NES. This NES. So what I always forget what's my NES. What's my NES viewer? What's my usual NES emulator? Sorry for that. I have to remember what's my NES emulator. Where do I have NES ROMs? Where do I have NES ROMs? No questions. Okay. Oh, no. Okay. I'm looking in the wrong directory. Of course, that won't help. Bespoke. FCUX. Oh, yeah, of course. And where? So, but poly. Where is it? Hashquines POCs. Yes. Does that work? Yes, that works. And I cannot. It doesn't want to go to the other screen. Oh, yes, here it is. So a NES polyglot, a NES payload that does the same trick. This time it's code that is running to identify the to read each bits. I mean, each side of the collision has bits to encode a final value to be displayed. And this was done by Evan Sultanik and Evan Terran. And this is not just a file in itself, it's a part of Poker GTF 14, which is uh, another Poker GTF issue, and it's showing the hash the it's showing the MD5 on the front page. So this is using JPEG trick. So again, displaying JPEGs, and then you flip the length of the comment in the. So this is a set of 32 image to be displayed, and the content of image will be will be selected by turning on or off each collision to write to so that you get the right digit to the right number to display, the right digit to display. And this file is also, let's see if I can just drop the PDF directly. So here's the PDF. No, it doesn't like it. I have to rename it as NES. Oh, come on. I have to rename it as NES. Doesn't work? Or did I crash the emulator? This happens. Surprisingly, not every emulator likes receiving. Oh yeah, and here is the same payload, and you see that earlier. Now this is the PDF that is running. So these are the same hash seafood that, if I recall correctly, Philippe Teven brute forced. So seafood, both the PDF and the NES polyglot are both displaying the same hash. And one is using JPEG trick to flip the digits, and the other is storing another set of hash collisions. It's not the same set of hash collisions, because again, the Nintendo ROM will not be able to address the whole file, which is 43 megabytes. So it's two sets of ROM. So this is why we ended up doing 608 hash collisions for that file, but we added an extra one so that we will see, where is it, GitHub, where is the Poco GTFO replo, where is it, tac. So issue 14, and you will see the hidden value, the hidden, then there is another collision for the image background. No, who cares about that? Open image, a new tab, and this is the actual issue where this is a hidden image with another hash collision, and again another hash collision, which means if you get this image to display, you will the MD5 is constant. Okay, so so an interesting fact is that you can and that will have some importance in a further stream, is that let's see, where's my hashquines. One of the scripts I did, you are able to you can, when you identify the hash collision. So how can you identify very simply a hash collision? Well, just flip it the usual way, and if the hash is still the same, then it works, which sounds a bit crazy, but this is exactly what my tool is about. So this is the scan script, and if you run it on a file, it will just try to flip every collision block, and if flipping a collision block gives the same MD5, then there is a collision there. And actually you can say, hey, this is a way that you can just take the file, and if it's the case, all these are IPCs, right, for hashquines, not chosen prefix, but identical prefix. And basically you can how can I say, you can flip a block to say, hey, get to size A or get to size B, and like, is it this one, it didn't work, then do it the other way around, and if the hashes are the same, then this is indeed a collision. And then when you identify the blocks of the collision, you Jason O'Connor, you're a hero, Ange. Thank you. Yes, but thanks, but why am I a hero? I'm not sure why I deserve that title tonight. So in this case here, you can even say, hey, reset this fast call to this side, or the longer side, or like, you can have different arguments. But basically, if you want to say what I call the shorter side is that when the value that is being encoded is smaller, is the smallest. So basically, even if you don't have the other file, you can reset Unicall and Fastcolls to their initial values, or set them arbitrarily and maintain the same hash. Okay, so these are all scripts that I used, and my scan script is is a bit slow, of course. It's very dumb, but it will locate which block the fast calls and UE calls are found, and that way you can even very easily do a script that will say, hey, flip all the collisions, flip all the collision to one side, and here is how it should be encoded. So here, for example, for the GIF from Rogdham, 6 characters are set by the MD5 is dead, and the rest is available. And for the NES, this are evenly spaced, so very easy to you don't need the block individual offsets of each block, the individual index, and you encode the value as bits in the file. So it's, as you see, it's not a very complex thing, because right now we're going to jump to more complex hashquines including those by David Buchanan. So yeah, so this is another script that I did. You get the idea. It's all available in open source. And now let's look at more advanced Hashquines, because that wasn't enough, clearly. So the POC4, and this beauty by David Retroid Buchanan. So you see it's a PNG, and the MD5 is displayed in a very special way on the side. And it starts with lead. And this is extremely special. Can I zoom? No, I cannot zoom. Yes. So the trick here is that with the hash collision, you can only, with the unicall, you can only flip one bit or another one. So basically, that's exactly what he did. You flip either one bit. None of the, this is sideways, this is isometric segment digits, so that each pixel to display is not on the same line. So basically, he ends up activating or enabling or not a single bit, and that way he builds the display of the hash, which is very impressive. And to fool us, there is also this pixel art. But now you notice that there's only one color in this file, which is exactly the trick, right? It's another trick that is very clever. Basically, all the it's using the whole palette, and basically only one color is visible. So if you put all the other palettes to back to visible, basically here you have a trail of different colors that all map to black. So it's like super clever palette abuse, because you can uh, flip one bit or not, that is the right value, and then all the other values are hidden in black and are the collision block that is ending the rest of the line. So like super clever. Yeah, like that was great, because again, you cannot hide data in a PNG date. Yeah. Sorry, I'm just reading again. For example, the first collision block defined atrocious but working PDF name. Whoosh. So Retroid put the collision blocks in plain sight. A custom palette is used to hide all colors but zero, and collision blocks containing null values are rejected. Very clever trick. Again, this is the way that he used this sideways segment display, and it's not segment display, it's pixel display. That's pretty impressive trick. And also there is the hidden the extra problem that you need to have the correct value for Adler 32, and basically Retroid came with a meet in the middle attack. I hope it's the link is still available. Yes, exactly, very clever work. Yeah, feel free yeah, to get, you need a fast collision, fast calls. Why? Oh, it's unicall, sorry. Is it unicall? It's fast call, or wait, it's a bit of both, right? It's fast call for the bits, and it's unicall for the CRC, if I recall correctly. And as you see, again, the fast call blocks to forge the CRCs are visible in the bottom of the page. So this is the same picture once you change the palette, and you see that you can still see leads, but it's the middle of different colors, and I chose blue because why not? And yeah, very impressive stuff. Very big combination, hidden in plain sight under a special palette. Very clever work. Yeah, but we didn't stop there. We didn't stop there. Oh yeah. What else did we do? So GZip, we saw it during this which for this hash collision exploitation. GZip can work with how can I say? Basically, you can, well, maybe it's better if I drop the, if I go find the hash collisions inside out. Yes. So basically, let's go back to the inside out presentation that was stream 19, where my tab, too many tabs open, where inside out. So let's go back. inside out. And basically, let's go quickly. GZip works with this is the first part on zip abuse. And GZip, this is very small. There is a magic, there is a method, there is from flags, a mod time, a time that we don't care about, some stuff, and then there is the data. And this is the minimum block to store in that's the compressed data. So this is like a footer, a header, and this is like the footer. And the footer says the CRC32 to be compressed and the length to be uncompressed. So basically, this is what is to say there is nothing to decompress. Now you can actually chain these things because they are called members. This is a whole member, and these are two. This is a file, again, a GZip file with a single member that stores no data, and the length of the data is indeed 0. But these are just two concatenated members that are both null, and okay, what can I say? And both members will be decompressed and the result concatenated, and still they both contain 0 data to be incompressed. Then the result is null. Now there is something that is called the extra field. There is a length for the extra field. If you set some bits set here to 4, I mean 4 bits, the bit 4 is set, then you will have the ability to have an extra field after this part. An extra field is able to store data, and then there is empty data body again, and with no compression. So basically, this makes a GZip member acts like a header, some contents. Here you can put arbitrary data, and a footer. So basically, no matter what's the actual, it's a file, but all the members will be decompressed. And of course, you can change the length of the extra field to encode some data or not, to jump over even another GZip file. So this is exactly what it does. So now we know that GZip members can be used to store data or not. And this is what I did. So you have a hashquine, and if you decompress the file, it's a text file and basically the hash is stored by having various information being compressed, and the structure of the overall GZip file activating or not which part to decompress. So basically, all this AD5DE is decompressed by having different pieces of the archive being decompressed selectively via different collisions. So this will make the file look very weird, full of many members. And then, of course, so this is a member. So let's see. This is a member. This is the signature of a GZip. This bit here, this flag says there is an extra field. Then you have the collision block extra field with the length just before, and you jump to another thing, and you see you chain GZip members, and that will activate or not some data to be decompressed or not. And eventually, after decompressing everything, you will end up being you will end up selectively decompressing some parts of the data. So here you can see that the bytes to be decompressed 0, then 1, then 2. So all this is to decompress the first byte to be displayed. So as you could see, now you could display by activating all these GZip members, you could make the 0, the 1, and the 2, and the 3 displayed for the first byte. So suddenly, it's not like it's exclusive. You could display everything, which is in a very special case of Hashquine, a very interesting case of Hashquine, where you don't need to have the whole set of characters to display to actually render a value such as an MD5. So for example, if your MD5 starts with 0, 1, then you only need to display the first member, to display the 1, and then you can say, well, I don't need that one. Of course, you cannot know in advance, but that's the thing. You may not need all the collisions to be computed to be already able to display the actual hash of the file. And this is exactly what happened. I just did a script that only works with a limited number of hash collisions because that was good enough. LZ4 is a bit similar, except that it has something even better. So I don't have a MZ4 LZ4 diagram with that, but Z standard is a bit similar. It's a compression format that has the ability. Hopefully you can see. It's a compression format that has the ability to have some frames that contain whatever you want. That will be and the frame is a special magic, and this is a magic range, not a single magic, but that doesn't change much for us. Then there is the size of the frame, and there is some data, and this will be ignored on the compression. So that's super powerful because then this is an official Z standard stream, and because made of frames, some frames will be skipped, some frames will be actually decompressed data. So it's making things very easy for us. And basically the same trick again. Let's do a frame via a switchable frame, skippable frame. Let's have the data to decompress a 0 or a 1. So let's see that how it looks for a LZ4. So that's my LZ4 file. So LZ4 and Z standard are similar. So you see the same values for the frame, skippable frame. Then there's a length, and then it's chained with another frame, and of course it lands inside a Fastcall block. And then there is a 0 here, and then there is a 1 here, and then there is a 2. So as you see, again, if we wanted to display some hash, we may not need all the ranges of values to be encoded, because in case we need that. And I think I showed an example of that. Where was it? So for example, if the fall, so in this was it this one was yeah, exactly, for my GZip hash I only needed in increasing number. If you are in increasing order AD 5DE, so I only need 12 groups of characters in increasing order. So it's possible to do it with less collisions than the actual total numbers that would be required. So as you see, an unexpected optimization. And now I think the best of this, so I did the LZ4, which is a bit similar, just encoding the LZ4 value. The GZip hashquine doesn't show. Oh, no, 192 MD5 Unicall MD5 collision to display 12 times. Okay, so see, I stored every digit 12 times. This is not enough to display any MD5, but I was able to display it nonetheless. So an extra small member with brute force content was happening to give the file an MD5 that can be displayed with this limited input. And now David Buchanan strikes again with a very impressive Z standard multi-hashquine. It's the same file. It's hard to believe, but basically it's enabling or not different parts of the output to be decompressed. And the output can be either pure text or also add a tar file, a tar header. So the file can be a valid tar and still contain. So before the display of all the digits to show the MD5, there is also the possibility to define a complete tar header, including the checksum. And even better, and that's the best part, is that then there is even a way to store a file that will contain itself the hash. Sorry, question? Oh, you are attending, David. I hope I'm saying your name correctly. I just remember this standard one has a zip hidden in there too, but I didn't write to flip code to flip the collisions. Are you sure? Because I did a script to do that. Or was it your plan? I'm not doubting you. The Z standard or the tar zip standard, or both? Because I did the script. Sorry. I did the script to I did the script, and I with my tool I could identify all the collisions, and I don't remember seeing the content of a zip file. It needs logic to fix the CRC32 in the zip. Okay, so but let's look at zip standard file. Is it always the same size? Because you did several. So do you say there is there is a, so yeah, it's funny, we can immediately recognize hash MD5 file, but there is a zip in there. Oh, okay. Okay. So how did I miss that? Because I pretty sure I looked at your whole file. Okay, maybe I didn't. Okay, interesting. Oh, you hit that even more. So you're watching, maybe I'm missing a ring, but yeah, I checked for magic. Yeah, exactly. I just saw them. Of course. PK34, dead beef. So you activated. So what did you want to do? You wanted to hide another. Uh, okay, no P5. Oh, okay. So you just started the initial. You just started the beginning of a zip, or because there's only the PK34, right? Which I just searched for. If I knew you would attend, we would have done a podcast version of it. This standard flavored zip. Ah, okay, okay, okay. So, okay, I see. So, yeah. So basically, okay. So it's a zip with the it's a zip with the method set to. So which byte is it? This is 5D, the byte of the method here. So basically, this is a zip set to. Is it here the method? But yeah, it should be here. What is it? Bytes. Oh, okay. Sorry. Yeah, byte 5D. Okay, that's the method. So it's you define a local file header. Oh, I missed that. You define a local file header with the standard method, compression method. Okay. Yeah. Okay. And you need to add the zip footer at the end. I see. I see. Oh, I missed that. Ooh, awesome. Good stuff. So, wow. Yeah, that's the first time I'm talking about a file and the author of the file is looking. No, you should be the one doing the stream. That's awesome. And yes, so basically, let's do the count of the MD5. And now I know that this count, the count of hash collisions, because I know this count is wrong. So there was one collision for the start to trigger on and off the header start, then some constant because of the writes of the file. Then there is the file size to be encoded, the timestamp, okay, which is constant here, okay, to set it off. Because remember why you need a one collision to set on or off the timestamp, because again, this file can exist without a tar header as a pure Z standard file. And now I just learned that it could be a zip Z standard at the same time. That's awesome. Then the tar checksum, to be a valid tar zip, the header needs to contain an exact checksum. And then the end of the tar header, which contains the tar magic, use tar, and so on until the end of the header, which is rounded to 512. Then the file contents, and then the last, and I'm wrong, and I'm still not sure how I missed that one, but there is a prefix for the text that you want. The MD5 of Hashquine tar is, or the MD5 of Hashquine, and you see that the text is slightly different. And is there a text for this zip? Anyway, Oh yeah, and of course the last part. No, maybe we forgot about that part. Displaying the MD5 hash itself with all the nibbles possibilities to not take any risks, even though that could be probably re-extended afterward. So that's a very far-fetched file, and even better is that you can disable collisions to get you a huge file that contains nothing with all the collisions, disabling the actual Z standard frame to be decompressed. So I think I covered everything. Oh yeah, and last another thing, yes. mm, David, thanks for attending, David, did this monomorph, which combines this idea of encoding data with a fast call with a small shellcode loader, so that you can have all kinds of different payloads having all the same kind of the same hash, exactly the same hash. So you can, of course, tell in advance the hash. I mean, it's constant, and you can make it a hashquine, or you can make it a rickroll or something evil, and you could encode any data to be executed that way. So good stuff, very advanced stuff. Did I mention everything for hashquines? We don't have enough. We don't have SHA-1 hashquines yet. I'm not sure why. Sorry, but I'm noob in these hash things, but they're interesting. Okay. So hashquine is the file that shows their own hash. Yes, indeed. But it also shows that hashes that are weak are a fun toy to play with, which means maybe it's time not to use that for actual security. When you so how many did you add, David, in your file? 653. Wow, that's even more than the Poker GTFO. So that's quite a number. So when you add 600 collisions in your file, then you know that the algorithm is quite weak, and yet the Radius protocol people were saying that it's safe because it hasn't been broken yet. Of course, it takes time to compute all these 609, but this time would just be reduced overall. I mean, in the future, even the fast call is already pretty fast, only a few seconds if you see my previous streams. So I think I'm done for today. One last round if you have questions, people. Thanks for David for joining and seeing me cover your own files, and shame on me for missing the zip uh, um, the zip local file header start. But yeah, that's super clever once again. You put dead beef as a CRC, right? Not a big problem. But yeah, very clever. And yeah, I think I'm done. If you have no more questions, congrats for everyone for doing these hashquines. And if you have no questions, then I will gonna see you next stream. And one of the next streams will be about detecting hash collisions and hash collisions mitigations in general, whether it's about detecting them once they are they are implemented, or whether it's file formats should be responsible for the creation of hash collisions or not. So once again, thanks for your time, and yes, see you next stream, I guess. So yeah, bye bye. See you next time. Thanks.